last video in this section, I just want to illustrate using this GeoGebra app how the level curves are going to relate to the 3D dimension or the 3D graph of a two-dimensional function, or a function in two variables, excuse me. So on the right-hand side, we have a function, and then on the left-hand side of the page, that we're going to have the level curves. And what you'll notice is that the blue part of this illustrates or relates to how this cross section is occurring. So remember, we said that we basically have a projection on the XY plane. That cross section is essentially relating what that two-dimensional graph looks like in the XY plane. So now remember one of the functions that we had x plus y divided by x minus y. And if you remember, we had a bunch of lines. So let's see what happens when we plug this into GeoGebra. And the 3D graph of this doesn't look all that pretty. Right? What you'll notice, though, is that we do indeed have these values right here that look like they're going to be the lines of the level curves. Now, it does seem that there are some spaces in these level curves. And I think those spaces are essentially some of the points where x is x minus y is 0, or in other words, x is equal to y. So there are some domain restrictions on this function, which is why we have some of these breaks that go on in here. All right, so be careful, or it might even be the asymptotic behavior of the three-dimensional function. Another equation that we looked at, one that gave us the ellipses, was x plus 4y squared. So let's see what that looks like. Or x squared plus 4y squared, excuse me. And not surprisingly, what we end up with is we have with an elliptic paraboloid that's concave up. And we're going to have to wait for this, unfortunately, to be able to get above the z-axis or the xy plane to be able to show all the different level curves. All right. Now, why does this stop? In other words, why aren't there level curves that go beyond this last one? It's just a limitation of the technology. In fact, there are an infinite number of ellipses that are going to that are the level curves of this. It's just that the technology only goes up so far with this. Remember, we have some circles for this one. We had square root of 9 minus x squared minus y squared. This was the last level curve that we plotted, and these were a bunch of circles. Right? So let's go ahead and plot this. It does take a minute. All right, and we end up with not a sphere, but a semisphere of this. It's not plotting a lot of the level curves. In fact, there are a lot more level curves in this. In fact, I think we found like maybe 2 or 3 of these. All right, this just gives us a couple of them. But you can see as this gets up to the vertex of the sphere, or at least one of the endpoints, we notice that indeed it does show all the different circles that are the concentric circles that end up being the level curves of this. So I do urge you to maybe play around with this, plot some different functions in 3 dimensions, and see what the level curves of those look like.